So in this video we're going to learn about graphing quadratic functions. Recall that the y-intercept is the y-coordinate of the point where a graph intersects the y-axis, of course. And at that point where a graph intersects the y-axis, the x-coordinate of this point is always 0. So if we look at our quadratic function in standard form, and if we let x equals 0 and plug in our zeros, you'll see that y equals c. So clearly, the y-intercept of any quadratic is the value for c. So let's take a look at some slides that show this. So I've got this quadratic, y equals x squared minus 2, that negative 2 is my y-intercept, and notice my graph does cross the y-axis at negative 2. Here I've got a c of positive 4, so my intercept with the y-axis is at 4. Here I've got the c value of negative 3, and so my y-intercept is at negative 3. We're going to use this y-intercept along with our knowledge from yesterday of finding the vertex and the axis of symmetry to go ahead and graph a quadratic. So there's a lot of notes here, and you're going to want to write all of this down. To graph a quadratic function, step 1. You're going to find the axis of symmetry just like we did yesterday. We're going to find the vertex and plot it. Determine if this is a maximum or a minimum, so we know if the quadratic is facing up or facing down, a smiley face or a frowny face. We're going to find the y-intercept and plot that, and then we're going to find 2 more points, and we're going to look for points that are close to our axis of symmetry, and then once we have those 2 points, reflect them across the axis of symmetry and then connect those. So let's go through an example of that. If you need to pause to write the rest of this down, go ahead. So our first step is to find our axis of symmetry. Well, I've got negative b, or negative 6, over 2a, and my a is 1. So my axis of symmetry is 3. So I know that over here on my graph, this is going to be my axis of symmetry. Okay, I'm just sketching this in. Next, I'm going to find my vertex, and I know that I take my 3 and plug it in. So I've got y equals 3 squared, or 9, minus 18 plus 5. So my vertex is at the x value of 3 and the y value of negative 4. So now I have my vertex at 3, negative 4, which I'm going to plot right there. So I know here's my axis of symmetry, and I know also that because this is a positive a, that my parabola is going to be upwards facing, so this is my minimum point. I'm going to look for my y-intercept, and as we just mentioned, that y-intercept is here at 5, so I know that it's going to intersect the y-axis right there at 5. And then I'm going to pick some additional points. So the point 1, because this is in between my axis of symmetry and my y-intercept. So I'm going to plug in the point 1 into my equation. I get y equals 1 squared, or 1, minus 6 times 1, or 6, plus 5. So my y for x equals 1 is going to be 0. I'm also going to try the point where x equals 2, so I'm going to plug my 2 in for x. I get y equals 2 squared, or 4, minus 12 plus 5. So I know that where my x equals 2, my y is going to be negative 3. Now I'm going to reflect these points across the axis of symmetry. Well, I'm 1 away from the axis of symmetry, so I know that it reflects to here. Here I'm 2 away. It's going to reflect to this point, 5, 0, and now I'm 3 units away from my axis of symmetry, so moving over 3, I'm going to be at 6, 5, and now I can draw, if I can do this neatly, my parabola that is the graph of this quadratic function. Okay, I'm going to actually walk through the steps of this, but if you can beat me to it, great, and jump ahead. So first of all, I'm going to have to put this into standard form. I've got y equals x squared minus 4x, because I brought my 4x back over to this right-hand side, minus 5. So now I can find my axis of symmetry. My axis of symmetry is 4 over 2, or 2, x equals 2. I've got a vertex of y equals 4 minus 8 minus 5, so my vertex is at 2, negative 9. So I'm going to go ahead and I've got my axis of symmetry here at 2, and I know that my vertex is at 2, negative 9. I'm going to identify my y-intercept, which is here at negative 5. And I'm going to pick 2 additional points. So I'm going to go ahead and pick an x value of 1. So y equals 1 squared, or 1 minus 4 minus 5. So at the point x equals 1, my y value will be negative 8. And I'm going to go ahead and pick negative 1 for my second value. So where x equals negative 1, my y equals 1 plus 4 minus 5, or 0. So where x equals negative 1, my y value is going to be 0. I'm going to reflect these points across my axis of symmetry. I'm going to be here, here, and here, and then I can go ahead and sketch. Alrighty, so I'm going to go ahead and do an application problem. So we can see a real-world example. So Maddie's diving into a pool, and the height in feet above the water at any time can be modeled by this function. F of x equals negative 16x squared plus 24x. I want to know how high Maddie's going to be when she reaches the maximum height of her dive, and figure out how long it takes Maddie to reach this height, and then how long it takes her to reach the pool. I'm going to use the same skills that I just learned in the previous slide. Pull out your notes. I know that I've got an axis of symmetry of negative b over 2a. So my axis of symmetry is at 3/4. So this is 1 1/2. Okay, so I know that my axis of symmetry is right here at x equals 3/4. I also have my vertex, y equals negative 16 times 9/16 plus 24 times 3/4. So my axis of symmetry is 3/4 and 9. So at 3/4 and 9, that's going to be my vertex. I have a negative a, so I know that this is going to be a frowny face parabola. I do, though, want to identify my y-intercept. I don't have a c, so that means my y-intercept is here at 0. And then I can find some points that I can plug in to find some other points on the parabola. So I'm going to go with 1/2. I'm going to plug in 1/2 here. So when my x equals 1/2, my y will equal, and I'm going to do the same for when x equals 1/4, equals 1/4, my y is going to be 5. So I'm going to plot that point, 1/4 and 5. Now I'm going to reflect those points over my axis of symmetry. And I can sketch my graph. One thing I do need you to take note of here, this is a real world example. Maddie cannot go beyond the bottom of the pool. Actually, this is really the top of the water, because that's what we're making the assumption. And she's not going to have negative time. So if time was on my x-axis and height is here on my y-axis, remember that I'm only going to be here in my first quadrant. So we asked several questions here. It asked me the maximum height of her dive. Well, the maximum height is the vertex of my parabola, so I know that my y value at that vertex is 9 feet. So the maximum height of her dive is going to be at 9 feet. And it asks me how long it takes her to reach that height. Well, that's the x value of that vertex, or 3/4 of her time was in seconds, so 3/4 of a second was how long it took her to reach that height. And then how long it takes her to reach the pool? Well, I've come back to 0 here at 1.5 seconds. So it is 1.5 seconds for her to reach the pool. I'm going to run through one more example with you, case that was a little confusing, and then you'll be on your own. So I've got a football being thrown. It's modeled by this equation, and I've got x is time in seconds. I want to know the football's maximum height, the time it takes the football to reach this height, and then find out how long the football is in the air if another player catches it also at 5 feet. So I'm going to go through the same process. And my vertex is, my axis of symmetry is at -b over 2a. So my axis of symmetry is at 2. My vertex is going to be where x equals 2, or 269. So I know I've got an axis of symmetry here at 2. So this is the point 2. And okay, so here I am at about 69. I'm going to find my y-intercept. Well, my y-intercept is here at 5. So I'm right here, and that's because the player is throwing it from chest height, or approximately 5 feet, as opposed to throwing it from the ground level. So my x-axis, my y-intercept, instead of being 0, is actually going to be 5. And I'm going to find my points in between. I'm going to find what y equals if my x equals 1. So I'm going to be around there. I'm not going to take too long with this, so I'm going to go ahead and sketch this graph, because I've got all the information that I really am going to need for this one. Remember, I've made the assumption that another player is going to catch it at 5 feet, so my parabola is going to be not quite touching my x-axis. The questions, though, are what is the maximum height? The maximum height the football reaches is that y value of my vertex, which is at 69. So I'm at 69 feet. The next question is how long it takes to reach that height. Well, that's my x value, because remember, this is time. So I want to know how long. Well, it reached that height at 2 seconds. Then I want to know how long the football's in the air until it's caught at 5 feet. Well, to get all the way back to where it started is going to be 4 seconds. So it was in the air for 4 seconds total. Okay, so you've got 2 questions to work on yourself to bring into class tomorrow. But in the meantime, I've got a little joke for you. What kind of tree could a math teacher climb? Geometry.